Alright, so this is about properties of operations. This is basically a little review. You should know the majority of this already. So in my first blank, a blank is a statement that is true for any number. In that blank, you're going to write property. So property is a statement that is true for any number. You may wonder if any of the properties apply to subtraction or division. If you can find a blank, an example that shows that a conjecture is false, the property does not apply. In that blank, you're going to write counterexample. So a property is a statement that is true for any number. You may wonder if any of the properties apply to subtraction or division. If you can find a counterexample or an example that shows that a conjecture is false, the property does not apply. Alright, so we have a couple of examples, so let's take a look at them. The first one is name the property shown by the statement 2 times the quantity 5 times n equals the quantity 2 times 5 times n. It's a little bigger. Okay. So the order of the numbers and variables don't change, but their grouping did. So this is the associative property of multiplication, and you can use the foldable that we learned about just previously, and it's on the previous page to help you with these. Okay, next I want to state if whether the following conjecture is true or false. If false, provide a counterexample. So division of whole numbers is commutative. So I write two division expressions using the commutative property. I have 15 divided by 3 equals 3 divided by 15. I want to know if they're equal. Well, 15 divided by 3 equals 5. 3 divided by 15 is 1/5. So they are not equal, so that's my counterexample. The conjecture is false. My last one I have is Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. I want to use mental math to find the total cost before tax. So I write an expression for the total cost. I can arrange the numbers or rearrange them in any order I want because I'm dealing with addition. Okay, so addition is commutative and associative. It doesn't matter how I group them or how I order them, I'll still get the same answer. So I can arrange the sums in ways that they're easy to look at. 38 plus 14, 22, and 16. So I know that 8 and 2 would give me 0 or a 10 value. Okay, same with 4 and 6. So 38 and 22 is 60, 14 plus 16 is 30, 60 plus 30 is 90. So the total cost of the items is $90. Alright, there are a couple of try problems, so I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. Alright, now that you've had a chance to try out the try problems, let's go over the answers together. The first one I have is name the property shown by the statement 42 plus x plus y equals 42 plus y plus x. So if you notice, I don't have any grouping symbols, so it's not an associative property, which means it needs to be commutative. So it's commutative property. And this is the commutative property of addition because I'm adding. Okay. It's really important that you include whether it's a commutative property of addition or multiplication. Super easy thing to recognize. If you're multiplying, it's commutative property of multiplication. If you're adding, it's commutative property of addition. Okay? The next one I have is state whether the following conjecture is true or false. If false, provide a counterexample. The difference between two different whole numbers is always less than both of the two numbers. Okay. So let's think about this. Two whole numbers. So pick any two whole numbers that you want. Let's say 8 and 2. Difference means I subtract. So 8 minus 2 equals 6. Is that number less than both of the two numbers? Well, 6 is less than 8, but it's not less than 2. So this conjecture is false, and we've already provided a counterexample. All right, my last try problem says Lance made 4 phone calls from his cell phone today. The calls lasted 4.7, 9.4, 2.3, and 10.6 minutes. Use mental math to find the total amount of time he spent on the phone. So I want to go ahead and create an addition expression. Okay. So here's my addition expression. Now I want to rearrange these by using the commutative property so that they're easier numbers to deal with. So looking at these, I know that 7 plus 3 gives me 10, so I can reorder those. So 4 plus 7 plus 2.3, and 9.4 and 10.6, 4 and 6 will get me 10. Okay, then I can add these together. So this is 7 plus 20, which is 27. Okay, the next one I want to talk about is the distributive property. So the expressions 2 times x plus 2 and 2x plus 4 are blank, blank. In those two blanks, you're going to write equivalent expressions. Okay. So those are equivalent expressions. No matter what x is, these expressions have the same value. Okay. So I can use the distributive property to evaluate. I have 8 times the quantity, negative 9 plus 4. So I multiply 8 times negative 9 and then 8 times 4. 8 times negative 9 gives me negative 72, and 8 times 4 is 32. When I add them together, I get negative 40. I can also use the distributive property to rewrite the expression. 1/3 times the quantity x minus 6. I can distribute the 1/3 to the x and to the 6th. So 1/3 x, and then 1/3 times 6 is actually 2. So 1/3 x minus 2. My last example, Mr. Ito needs to buy batting helmets for the baseball team. The helmets he plans to buy are $19.95 each. Find the total cost if Mr. Ito needs to buy 9 batting helmets for the team. So I can rename $19.95 as $20 minus 5 cents, then use the distributive property to find the total cost mentally. 9 times 20 is 180, and 9 times 5 cents is 45 cents. So when I subtract 180 minus 45 cents, I get $179.55. So the total cost of the helmets is $179.55. All right, there are a couple of try problems on this page. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So the first one I have is use the distributive property to evaluate. So I have 5 times the quantity, negative 9 plus 11. So I distribute the 5 to everything inside the parentheses. 5 times negative 9 is negative 45, and 5 times 11 is 55. Negative 45 plus 55 is positive 10. My second problem asks me to use the distributive property to rewrite the expression. I have the quantity m plus 3n times 8. It doesn't matter which side your whole number is on, or whatever is outside the parentheses. It just matters that you distribute whatever is on the outside of the parentheses and multiply by each item and term inside your parentheses. So I multiply 8 times m and 8 times 3m. 8 times m is 8m. 8 times 3 is 24, and the n tags along. All right, my last question on this page is a sports club rents dirt bikes for $37.50 each. Find the total cost for the club to rent 20 bikes. Justify your answer by using the distributive property. So I can rewrite $37.50 in several different forms, whichever one is easiest for you. I'm going to rewrite it as $37.50 can become $37 plus Okay? Then I'm going to multiply this times 20. 20 times 37 is $740. And then 20 times 50, so 740 plus $10 is $750. So sports club, the total cost to rent the bikes for the club is going to be $750. All right, my next page that says the distributive property is this one, okay? When numeric or algebraic expressions are written as a product of their factors, the process is called factoring the expression. So that's what goes in those three blanks, factoring the expression. So basically all factoring is what can I take out from the inside parentheses and put it on the outside? What can I factor out, okay? So I can factor the GCF out of an expression. I have 4x plus 8. Okay, so I have 4x plus 8. So I know that 4x is really 2 times 2 times x, and 8 is 2 times 4, which is 2 times 2. Okay, they both have a 2 in common and another 2 in common. That means that's my GCF. That's what I can take out of my expression. So if I take 2 2's, which is really 4, I am left with x plus 2. All right, so let's look at one of the examples we have. It says factor 12 and 8. So what I can do is actually create either a factor tree or I can list out all the factors. So the factors for 12, I can say 2 times 6 is 12. 6 isn't prime though, it's a composite number. 6 is equal to 2 times 3. Okay. And then for 8, we know is 2 times 4 and then 2 times 2. So they have a 2 in common and a 2 in common and another 2 and another 2. So I can take out 2 2's, which is really 4. So the GCF, greatest common factor, is 2 times 2 or 4. I can do the same for all of these. Okay? Anytime I factor something out, I'm looking at what can I take out of both equally, okay, or any term equally. You can have more than 2 terms when you're factoring, but you're still looking at what can I take out of each of those terms equally. All right, so there are a couple of try it out problems below. I want you to go ahead, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So the first one I have is 5 times 2 2/5. Okay, so when I do this, it's really like saying 5 times 2 times 2/5. Okay, so 5 times 2 is 10. And 5 times 2 is 10 divided by 5 is 2, so this is 12. 12 times 3 1/3, which is really like saying 12 times 3, which is 36, plus 12 times 1/3, 12 divided by 3 is 4. Which is 40. Okay. Then for C, I have 3 times 2.4. So 3 times 2 is 6. 3 times 0.4 is 1.2, so this is 7.2. For letter D, I have 5 times 6.2. So 5 times 6 is 30. 5 times 0.2 is 1.0. 30 plus 1 is 31. Letter E. So for letters E through I use the distributive property to rewrite each expression. So I have 8 times x plus 4. So I'm distributing the 8 to everything inside each of the terms. So I get 8x. 8 times 4 is 32. Okay. For letter F, I distribute 6 times 9 is 54. 6 times x is 6x. G, x plus 3 times 2. Again, it doesn't matter which side it's on. 2 times x is 2x. 2 times 3 is 6. For letter H, 5 times the quantity x plus 6. So I get 5x plus 30. Alright, for letter I, each day Mr. Martin lifts weights for 12 minutes and runs on the treadmill for 30 minutes. Write 2 equivalent expressions and then find the total minutes that Mr. Martin exercises in 7 days. So, we know that he exercises for 30 minutes and lifts weights for 12. So I have total number of minutes, and I'm multiplying that by 7. Okay. So 30 plus 12 times 7. We could also say this equals 30 plus 12, which gives me 42. So 42 times 7. Okay. We could also say 30 times 7 plus 12 times 7. Okay. 30 times 7 is 210, and 12 times 7 is 84. Okay. And then 210 plus 84 is 294. So Mr. Martin exercises for 294 minutes in 7 days. All right, for the last one, I want to factor out the expressions. So I want to figure out what I can take out of each one of these. So for J, I have 9 plus 24. So I'm going to go ahead and make a factor tree. 9 is 3 times 3. 24. Okay. They both have a 3 in common, so 3 is what I can factor out. When I'm left with 9, I have 3, and then 2, 4, 8. Left with 8. So 3 plus 8. Okay, for letter K, I have 14 and 56. So 14 is 2 and 7. 56 is 2. And 28. 28 is 2 and 14, which is 2 and 7. So they both have a 2 and a 7, so that's what I can factor out, which is 14. All right, when I factor out 14, you want to ask yourself, 14 times what gives you 14? Well, 14 times 1 gives you 14. Okay? And then I have
the answer is
4 left. So for this one, I have 14 times 1 plus 4. Okay, for 80 and 90, I can factor out 10. So I have 8 plus 9 left. For 14x plus 12, so 14, I have 2 and 7. 12 is 2 and 6, which is 3 and 2. So they both have a 2 in common, so 2 is what I can factor out. I have 7x left, plus 6. For n, I can factor out a 7, and I'm left with x plus 3. You can always go back and double check these. You can always go back and say, well, if I multiply 7 times x, do I get 7x? If I multiply 7 times 3, do I get 21? Answer is yes, so you factored correctly. 16 plus 8x, I can factor out an 8. Okay. You can also write this as 1x. Either way, it's the same. 30 and 36. 30 is 5 and 6. 36 is 6 and 6, so they both have 6 in common. So 5 plus 6x. And then 150x, they both have a 50 in common, and that's 2 plus x.